All right, today we're tackling what is, and I'm not kidding, probably the single most important diagram in all of trigonometry, the unit circle. Seriously, if you can really truly get your head around this one thing, you basically unlock everything else.
So you probably remember SOHCAHTOA from school, right? Sine, cosine, tangent. It's awesome for right triangles. But it has a huge blind spot. I mean, what do you do when an angle is negative, or goes all the way around, 360 degrees, or even bigger? A simple little triangle just can't handle that stuff. We need a bigger, better tool.
So here's the game plan for how we're going to break this all down. First, we'll see exactly why our old way of doing things hits a wall. Then we'll introduce the star of the show, the unit circle, and uncover its biggest secret. After that, we'll get our hands dirty with some practice, I'll point out a few common mistakes to avoid, and then we'll get to the really cool part, why this all matters in the real world.
Okay, let's dive right in. First up, triangles have limits. We need to understand the problem with good old SOHCAHTOA so we can appreciate why the solution is so brilliant.
You see, the whole world of SOHCAHTOA lives and dies inside a right triangle. And since all the angles in a triangle have to add up to 180 degrees, we're stuck. We're pretty much restricted to only working with angles between 0 and 90. To really understand rotation and the full universe of angles, we've got to break out of that triangular box.
And that's where our hero makes its grand entrance. Section 2. Let's meet the unit circle. This thing might look simple, but trust me, it's a portal to a whole new world of trigonometry.
So what is this thing, this magic circle? Well, the definition couldn't be simpler. It's just a circle. Its radius is exactly 1, and it's parked right at the center of a graph, the origin. The real magic here isn't that it's complicated, it's that it's so incredibly simple.
Okay, so there are just 3 simple rules you gotta know. 1, its center is at 0, 0. 2, its radius is always 1. And 3, thanks to Pythagoras, any xy point on that circle has to follow the equation x squared plus y squared equals 1. That's it. Everything else we're about to do is built on these 3 simple facts.
All right, you're going to want to lean in for this next part because this is it. This is the big aha moment. This is where we connect the old world of triangles to this powerful new circle.
So what we're going to do is take our old friend, the right triangle, and actually put it right inside the unit circle. Just imagine drawing a line from the center out to any point on the circle's edge. That line is our hypotenuse. Then you just drop a straight line down to the x-axis and bam, you've got a perfect little right triangle living inside the circle.
All right, let's connect the dots here. We know from SOHCAHTOA that cosine is adjacent over hypotenuse, right? Well, look at our new setup. The adjacent side of that triangle, that's just the length along the x-axis, which is just the x-coordinate of our point, and the hypotenuse, that's the radius of the circle, which we already know is always 1. So cosine is just x divided by 1. Or, even simpler, cosine is just x. And using the same exact thinking, sine, which is opposite over hypotenuse, becomes y over 1. So sine is just y. And that, right there, is the big secret. This is the whole shebang. Any point on that unit circle isn't just some random xy coordinate. It's literally telling you the cosine and the sine of that angle. The x value is the cosine. The y value is the sine. That one simple idea changes everything.
And just like that, unlocking that secret gives us our first major power-up. Remember that equation for the circle, x squared plus y squared equals 1? Well, if we just swap in our new definitions, if x is really cosine and y is really sine, then we get cosine squared plus sine squared equals 1. This is the famous Pythagorean identity, and it's probably the most useful, most important identity in all of trigonometry.
Okay, so we've got the theory down. Now let's get our hands dirty and actually use this new tool. This is where it all starts to click.
All right, let's start with a really straightforward one. The question is, if a point on the circle has the coordinate 0.8, 0.6, what's the cosine and sine of the angle? Well, since we know x is cosine and y is sine, the answer is staring us right in the face. The cosine is 0.8 and the sine is 0.6. It's literally that simple. You just read the coordinates.
Okay, let's ramp it up just a little bit. What if we only know that the sine of our angle is 3/5? No problem, we just whip out our new Pythagorean identity. We plug in 3/5 for the sine, do a little bit of algebra, and we solve for cosine squared, which gets us 16/25. Then we just take the square root. And, this is key, the question tells us we're in quadrant I, where all of the x values are positive, so our answer has to be the positive one, 4/5.
All right, next up, let's talk about a couple of common mistakes, the little traps that everybody falls into so you can just sidestep them completely.
Okay, this first one, this is without a doubt the #1 mistake people make. It's so easy to accidentally swap them, but you have to burn this into your memory. Cosine is the x-coordinate. It goes side to side. Sine is the y-coordinate. It goes up and down. Always. No exceptions.
But hey, I've got a little memory trick for you that makes it super easy. Just think to yourself, X is for cosine. It's a silly little thing, but it'll save you from so many headaches, I promise.
The other huge pitfall is totally forgetting about negative signs. Remember, this circle lives in all 4 quadrants of the graph. So if you're over in quadrant 2, your x value is negative, which means your cosine has to be negative. If you're down in quadrant 3, both your x and y are negative, so both cosine and sine are negative. You've got to watch those signs.
Okay, for our last section, let's pull way back for a second. You might be thinking, this is cool and all, but is it just for a math class? So why does any of this actually matter?
Because here's the thing. This isn't just some abstract concept for a math test. Nope. The unit circle is actually fundamental to the technology you're using probably this very second. It is quietly working all around you.
Let me give you a mind-blowing example. Every single wireless signal, think Wi-Fi, your cell phone's data, it all travels as a wave. Your phone uses a process called IQ demodulation, which is a fancy way of saying it takes that incoming wave and breaks it down using the unit circle. It separates the signal into its cosine part and its sine part. That is literally how your phone translates a radio wave into the data you see on your screen.
So think about that. This simple circle we've been talking about, it's not just a drawing in a textbook, it's actively decoding the Wi-Fi signal that might be bringing you this explainer right now. It makes you wonder, doesn't it? If the unit circle is the secret key to something as complex as wireless data, what else in our digital world is being shaped by this perfect, simple diagram?